Welcome back to How to Program. Just a warning, this show is best viewed in order. We really recommend that you start with the first episode and then go through the series in sequence. This is how the show was conceived. This is how the show is put together. And so if you jump out in the middle and just start with this video and you've never seen any of our other videos, I really recommend you just click on our channel name, go back to video 1, and go through all the videos. It will make a lot more sense that way. Okay, so this is episode 9, binary. And we're going to talk about base 16 counting. So a little review first. We're going to talk about counting systems here, and counting systems they vary depending on how many symbols you want to use to represent numbers. Humans having 10 fingers, they use 10 symbols or 10 digits to represent numbers. That starts at 0 and it goes all the way to 9, and that makes 10 different possible symbols that you can use to represent a number. Now, computers having only 2 possible ways of representing a state, which is electricity is flowing or electricity is not flowing in their electrical circuits or in their electronic circuits. They only use 2 digits or 2 symbols to represent numbers, and they just use a 0 or a 1. The number of symbols in your counting system is called the base. That's what we call the base. So humans count in base 10 because 10 symbols, and computers count in base 2 because they have 2 possible symbols. There's another system which is used in computer science pretty often, which uses 16 symbols for counting. And the symbols that are used start at 0, go to 9, and then they start with the alphabet. They go A, B, C, D, E, F. The 6 first letters of the alphabet. Usually capitalized, sometimes not. So both is okay. And this system is called base 16, obviously, because there's 16 symbols. It's also called hexadecimal. And sometimes it's referred to as a hex or hex code or hex number. So the origin of that is Greek. Hex means 6, and decimus in Latin is 10. And so they put it together. I don't know why they mixed Greek and Latin. Don't ask me, but it sounds pretty cool. So hexadecimal means 6 and 10, or 16. So here are the hexadecimal values in the middle. And on the left, we have the decimal, which is the human counting system that you're used to using every day. And then on the right, we have the binary counting system, which at this point you should be pretty familiar with. So let's take a look. Hexadecimal very conveniently can represent all the numbers from 0 to 15. This is all the possible values we can represent in 4 bits, which means when you have a basic unit of memory called a byte, which is 8 bits, you can represent that value with only 2 hexadecimal symbols or hexadecimal numbers. So this makes it a very sort of simple way of representing, or a very compact way of representing the values that are in our memory. Here are some examples of binary numbers, and you can see that the hexadecimal number that corresponds with that number is very compact. Like for 8 bits, for example, for the first line here, we have 0001. Well, that's a 1. So in hexadecimal, that's also a 1. And then we have 1111, which is 15 decimal, and that's an F in hexadecimal. So for those 8 bits, we just need 2 hexadecimal numbers to represent it. You can see also with the further examples, like all the way down, if you have 32 bits, that takes up the whole line in binary. With hexadecimal, it takes like a quarter of the line. It's a very compact way of showing the data. There's a lot of uses for this. One of the main ones that I see a lot is representing colors. So if you know a little bit about colors, there's a thing called primary colors. The primary colors are red, green, and blue. And these colors are called primary because you can make any other possible color that you can see from just combining red, green, and blue. So these are the primary colors, because every other color is made from these 3 colors, basically. In computers, a common way to represent a color is to use 8 bits for each component, like each primary color, basically. And 8 bits is a value from 0 to 255, unsigned, no negative, positive, whatever, just positive. And so red gets 8 bits, green gets 8 bits, and blue gets 8 bits as well. So when we represent this in hexadecimal, that turns into just 6 digits to represent any possible color in the world that you could think of, which is very cool. So for example, if you wanted this bright purple here, I think it may be a little pinkish purple. But anyway, it's a purple. For the purposes of this video anyway, don't leave comments saying this is not purple because, I don't, I'm not picky. I agree with you. It's not exactly purple. But anyway, this might be represented as full red. So, 255 as the value for red, 0 as the value for green, and 255 as the value for blue. And if we represent this in hexadecimal, it turns into a color code FF00FF, red, green, and blue. So this is very, very convenient for representing this. Another thing that you will see hexadecimal used for is when you're looking at the raw values in memory in your program that's running, like what is actually in your memory. If you tried to display this in binary, it would be very big on the screen. And so usually the program represents it in hexadecimal because it's a lot shorter. So you can fit a lot more memory values on screen with hexadecimal. So it's good to know how hexadecimal works, which I just explained. You don't need to know any more than this, really. Like you can, if you want to play around and learn how to convert from hexadecimal to decimal or from hexadecimal to binary or from binary to hexadecimal, you can do that. That's fine. You can go back in the video and look at the table and make some examples and whatever. It's okay. I personally just use a program to convert this. I don't try to remember how to convert hexadecimal because, it's just very complicated. 16 values, that's a lot. And like multiples, like trying to multiply something by 16 and like that's just very complicated. So you can just use a calculator. The calculator on your computer actually will usually let you do programmer calculations. If you look in Windows and Mac, they both have this thing. If you go in the menu under View and you set the view to Programmer View, it will let you see a number's value in binary, a number's value in hexadecimal, and go in between all three representations. So that's, it's a very simple way of doing that so that you don't need to remember it in your head. There's another thing to know here is that when numbers are being shown, sometimes it's confusing to know which counting system are they using? You know what I mean? When we have all these possible counting systems that we can use. So if there's a 0x before the number, this means this number is in hexadecimal. So the number that comes after the x is hexadecimal. The 0 is not part of the number. It's just part of this 0x, which just means this number is in hexadecimal. So for example, 0x11 is 17 in decimal. It's a hexadecimal number, right? So it's 17. Binary numbers are also sometimes written starting with a 0b before the number to indicate that the number is written in binary. Because if you didn't know, you might think this is like just a decimal number that just has a bunch of ones and zeros. You know what I mean? So 0b, again, doesn't have any other meaning than this number is in binary. And the 0 before the b is not part of the actual number. So for example, 0b1111, that's 15 in decimal. So you can see how you could get confused if you didn't have this, because if you just saw 1111 and 11, like you would be like, well, the 11 is smaller, but because they're different counting systems, the 11 is actually bigger because it's in hexadecimal. So it's important to know which counting system is being used. In the next lesson, we'll go over how text is stored in binary, which is probably the last thing we'll need to cover in binary. We've covered numbers, we've covered fractional numbers, negative numbers, addition. We didn't cover multiplication and other things like that of numbers because the computer does that for you and you don't really need to know how to multiply in binary. You're not going to use that. So I didn't cover that. And we're going to cover how text is stored because this is very important. This you're going to need to know. So that's our next lesson, and I look forward to seeing you then. And you can also like our Facebook page to get updates as soon as the episodes come out, and I really recommend you do that. And if you really like our channel, you can also like the video, comment, and subscribe and let us know that you like it. All right, we'll see you next time.